Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Evolution by Blobs, and here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Along a zipper line, pairs of digits equidistant from the center of the line sum to the digit in that cell. So for example, in this line, the digits that are equidistant from the center, which is marked with a circle, sum to the digits in that cell. So for example, these two cells must equal the same as this one. These two cells must sum up to the same number. These two cells must sum up to that number here. These two cells must sum up to this number, and these two cells must sum up to this number. So basically, all along the zipper line, pairs of cells that are equidistant to the center must sum up to what the center is. Okay, and that's how zipper lines work. Black dots separate digits where one is a double the other. So these are called black Kropke dots. And for example, if this were a 2, this would have to be a 1 or a 4 to maintain the 1 to 2 ratio. And that's all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so first things first. This has to be a 1-2 ratio, and it cannot contain a 6. So it must be 1, 2, 4, 5, 4 or 8. These could be so the difference between this must be the same as the difference between these two, because these, as I showed earlier, let's do that again. We had green, orange, orange. I think these were red, I don't know. And these were blue, right? So these two values sum up to the same thing, sums up to green, which is sum up to the same thing that these two blue values sum up to. And these yellows sum up to the same, and these pinks sum up to the same. Now the only information we have is these two, the difference between these two must be the same as the difference between these two, right? Actually, we have these two must be the same as these two with this one too. Okay, and therefore, so these have to be 1, 2, 3, 4, 6, or 8, right? This is also 1, 2, 3, 4, 6, or 8. This is 1, 2, 3, 4, and 8. So this is 1, 2, 3, 6. I can't be 3. 4, 6, and 8. Right, because it can only be 3, 6 this way. If that's a 3 and that's a 6. Similarly, this is 1, 2, 3, 4, 6, and 8. This is 1, 2, 3, 4, and 8. So, but the thing is, these differences, so this difference is the same as that difference also. So, if this were 1 and 2, the problem is, if this is 1 and 2, that would equal the same as these two, right? Because the difference between this would have to be 1. So therefore the difference between this would have to be 1. And the only difference between two digits that have a difference of 1... Oh, actually. Yeah, aren't these all the same? Because if this is 1 double 2, that means you have a difference of 1. And you have a difference of 1, which must be 1 double 2. If this is a difference of 2, it's 2 double 4. Then therefore this must be 2 double 4 too, because the difference must be the same to add up to the same digit here, right? Same thing with 4. If this is 4 double 8, that means the difference is 4, which means this difference has to be 4, which is also 4 double 8. So this, first of all, then, this can never be 3 and 6, right? Similarly with this has, so this set of 1 to 2 ratios must be the exact same as this set of 1 to 2 ratio, right? Therefore, the red actually is not the same as this red, but it must be the same as this blue. So we can actually flip this. This red is the same as this red, or this cell, and this cell is the same as that cell. Therefore, we can swap these, actually. We can swap these. Let's swap these. So then, therefore, this is blue, and this is red, right? Because we know the differences have to be the same, and because the differences have to be the same, and they add up to the same number, we know the differences are the same because basically, again, these two cells add up to this number, and these two cells add up to that number, right? So if you take one, if you just have simple mathematics and you have the equation, right? You say this is A, this is B, this is C, this is D. A plus B must be equal to C plus D, right? Just by the definition of the zipper line. So this is A and B, C and D. So A plus B, actually let's make this A, B, C, D. So A plus C, actually let's make this A and D, and this is B and C. So maybe that will make things easier, right? So you have A, here you have A, this is B, this is D, then this is C, right? A plus D, again, equals B plus C. So if you subtract out B from both sides, then you get, right, A plus D plus equals B plus C. You subtract out B from both sides, and you subtract out D from both sides, you get A minus B equals C minus D, right? So therefore, and you know the 1 to 2 ratio has to stay the same. So therefore the difference between A minus B is equal to the difference between C minus D. Well, the difference, since the differences are the same, it has to maintain the same 1 to 2 ratio. The 1 to 2 ratio becomes the difference, right? The 1 in the 1 to 2 ratio becomes the difference. Therefore, you have to have the same two pairs to be here. And in addition, you know that these are the larger ones, so they therefore have to be the same. That's how you know that. And similarly, you have that too here, right? So we're going to remove these. We're going to move those. We're going to move those. So this has to be exactly the same because it's the same principle. It's not necessarily the same digit to add up to the same thing. And it's not even the same value necessarily that it adds up to. But it must be essentially the same, right? Therefore, actually, you know it cannot be 4 and 8 because 4 and 8 add up to 12. So it could be 2 and 4 or it's 1 and 2, right? If it's 1 and 2, that means it adds up to 3. So this has to be 2 and 4 or 1 and 2. So therefore, 2 cannot be in the rest of the column because we know the 2 is there. 2 can't be in the rest of the column. Therefore, this cannot be 1. Again, this can't be 4 and 8 because of the same reasoning here. Therefore, this must be 3 and 6. So this must be 3 and 6 because it must be the same again. So we're going to make this orange. This is going to be green then. So these two are the same, and these two are the same. And we know it's 3, 6 here. So this cannot be 3 and 6 either. This can't be 3. So therefore, this can be 2 with 1 or 4, and 8 with 4. So this is 2 or 4. This is 1, 4, 8. So this could also be, if it's 1, it's 2. If it's, this could be 8 too. So this is 1, 4, and 8. If it's 1, this could be 2. If it's 4, it could be 2 or 8. If it's 8, it has to be 4. So this is 2, 4, and 8. So we know this is 3 and 6. We know this is 3 and 6. This has to be, so therefore this has to be, adds up to 1 and 2. So that's 3. Or 2 and 4. So therefore it's 5. Therefore this can never be 8. So this is 2 and 4. So this is 3 and 5. And this has to be 9 then. Okay. This could be 1, 2, 4, 6, or 8. We're not gonna we're gonna remove these colors. So this is 2 or 4. So this has to be 9. So since this is 2, 4, and 8, this must be correspondingly 1, 5, and 7. We don't know about these differences. So in box 2, where can the 9 be? The 9 can never be on a zipper line unless it's the center, because obviously 9 plus another digit can never equal the same as another digit. So therefore, this is a 9, or it can be off the zipper line. So one of these two is 9. Similarly, this can't be 9, these can't be 9, and this can't be 9. Therefore, 9 must be one of these two. So since we know the 9's here, 9 has to be here. This can't be 9 because it's not the center of the zipper line, so therefore one of these two is 9. This can't be 9. Where is the 9 in column 7? Cannot be any of these. These because of the black crop key dot, and 9 can never be next to a black crop key dot, and this one is eliminated by that. This 9 is eliminated by this one. This 9 is eliminated by these pair. Therefore, this must be the 9. So this can't be 9. Okay, where is the 9 in box 3? It cannot be here. It must be one of these two or this one. Let's see. So this cannot contain 3 or 6 or 9. So this is 1, 2, 4, 5, 8. 1 and 2. Actually, 2 could be the center of this zipper line because this could be 1 and 1. So this can't be 1, but it could be 2, 4, 8. Oh, we're missing 7 too. So 7 could be here. So 8 can never be here on this zipper line because it can only add up to at most 8. So this can't be 8. This is 1, 2, 3, 4, or 8. So it must be with 1, 8, 2, 7, 3, 6, or 4, 5. So that's there. So the 9 in column 3, though, could be here, or here, or here. That's still a very wide variety. Okay. So if this is, okay, this is adds up to either 3 or 5. So therefore, the digits along the zipper line that connect to it must be from 1 through 4. Right? Therefore, this is 1 through 4, this is 1 through 4, this is 1 through 4. Okay, so if this is 3, this becomes 1, 2, 1, 2. So therefore, this would have to be 4 and 8 to be, if that were the case. Right? If this is 5, it either is 1, 4, or 2, 3, right? That add up to it. If it's 2, 3, then this would have to be 4, 8. If it's 1, 4, well, it can't be 2 anymore. So it must be 3 and 6, right? Because 1 and 4 are eliminated, so therefore 1, 2 and 4, 8 are not possible as a pair here. Therefore, this would have to be 6 and this would be 3, if that were the case. Therefore, this specifically can be only 1, 8 to add up to 9, or it's 5, 4 to add up to 9, or it's 3 and 6. So those are all possible. So either this is 2 and this becomes 1, or this is 4 and therefore... Isn't that 1 either way? I guess this could be 3 also. If this is 2, this could be 3 also. Right. Okay. If this is 3, this becomes 1, 2, 1, 2. This becomes 4, 5, 4, 5. Because there's no 1, 8 possible, no 2, 7, and no 3, 6 to add up to 9. If this is 5, this could be 1, 4, or it's 2, 3. If it's 1, 4, then this is either 2, 7, cannot be, it's either 2, 7, 3, okay, so this could be any of them then. The more limiting one, therefore, is definitely the 3, right? So say this was 3. This is forced to be 1, 2, 1, 2. This is forced to be 1, 2, 1, 2, which means this can't be 1. This can't be 1. This has to be 2. Therefore, that's 1, which forces this to be 4. This cannot be 2, 4, or 1, so it must be 1, which makes that 2. Again, this has to be 4 and 8. Which would make this 1 and 5. This again can't be 1, so this can't be 8. So far that's looking okay. This can't be 1, therefore this would be 2. This would be 1. This could not be 2, so this would be 4, which makes that 8. So far this is looking fine. That's 5. This can't be 1, therefore this is 5. This would have to be then 4 to add up to 9, and this would therefore be 8. So that's looking all good. This would obviously be 6, this would be 3, which would make this 6 and this 3. Huh. What would be the remaining digits here? This would have to be 3, 6, 7, and 9. Obviously, 7 could not be here, so therefore this would be 9 with 3 and 6, so this would be 6 and 3, 7. I'm thinking this is actually solving it. This is 9. This would have to be 3 and 6 also. Yeah. So that looks fine. Going that way. What about if it's 5? The problem is 5 gives you more options, right? Well, let's first actually try this being 3 then. If this is 3, this has to be 6. Ah, it cannot be 3 and 6. There we go. Okay, we've just shown it can't be 3 and 6 here. If this is 3, it has to be 6, but then therefore this must be F3 added up to 6, right? Because of the zipper line. So that doesn't work. Therefore, this can never be 3. This has to be 4 and 8. Which means we have a 4, 8, 4, 8 pair in row 5. The rest of the row cannot contain 4 or 8. So this can't be 4. This can't be 4. Since this is 4, 8, it must be it must add up to 9 with this digit, because this is 9. So therefore, this specifically becomes 1 and 5. Oh, that's interesting. Now we have this is either, these two is either 2, 1, and this is 5. Oh, sorry, and this is 3, which makes this 5. Or this is 2 and 3, which add up to 5, and therefore this is 1. We have a 1, 2, 3, 5 quadruple in column 5, which eliminates 1, 2, 3, and 5 also. So there's no 1, 2, 3, 4, 5, 8, or 9. So this must be 6 or 7, and this must be 6 or 7. Okay. So this can't be 4, though. We know that for certain. Because if there's a 4, 8 pair in box 2. So this can't be 4. Therefore, this is 2. Therefore, this has to be 1 or 8. We're not sure which. So this is 2. This then cannot be 2. Where is the 2 in this now in column 5? It can only be here. So this is 2 now. We don't know if it's 1 or 3, or if that's 1 or 5, or if this is 1 or 3. Okay, so 2. Wait, this can never be. This is not 1 and 8. It's 1 or 4. So now we have a 1, 2, 4 triplet also in column 7. What are the rest of the digits? It has to be 5, 7, and 8. This can't be 8 because it cannot add up to 9 anymore. So therefore, this is 5 or 7. This is 2, so this cannot be 2. So this can't be 2 anymore either. So if this is 4, it has to be with 8. If this is 8, it has to be with 4. This can't be 1. So we have a 4, 8, 4, 8 pair now in row 9. So the rest of the row cannot contain 4 or 8. So this can't be 4 or 8. Okay. What does this add up to? What can this be essentially? Obviously, it could be 9, and if it's 9, then it has to be with 3 and 6, because 2, 7, and 1, 8, and 4, 5 are eliminated because of the 2, 4, 8 that is already in the box. Therefore, if this is 9, this has to be 6, and this has to be 3. Can it be 7? If it's 7, it could be 1 and 6. It cannot be 3 and 4, and it cannot be 2 and 5. So this could... Wait, hold up. Yeah. If this is 7... It has to be 1 and 6. It cannot be 2, 5, or 3, 4. Can it be 6? If it's 6, it has to be 1 and 5. So that does work. It cannot be 2, 4, obviously. If it's 5, it can't be 1, 4, 2, 3, so it can't be 5. If it's 4, it could be 1, 3, and 1, 3, but the problem is there's a 1, 3. That would eliminate all possibilities for this cell and for that cell. Therefore, if it's 9 again, it has to be 3 and 6. Which means we have a 1 and a 3 here, right? Or this has to be 1 specifically. This has to be 3 with the 6. If it's 7, it has to be 1 with the 6. And if it's 6, it has to be 1 with a 5. So this always has a 1 or a 3. And this cell must be 1 or 3. Therefore, in the box, you cannot have another 1 or 3. So this can't be 1 or 3. Similarly, in the column, this is a 1 or 3. this must contain the 1 or 3 also. So the rest of the column cannot contain 1 or 3. Therefore, this can't be 1 or 3. This can't be 1 or 3. So this is 2, 4, 5, 6, 7, 8. Which means this is 1, 3, 1, 2, 3, 4, 5, 4, 5, and 7 to match, to add up to 9. This can't be 2, obviously, because of that 2. Therefore, this can't be 7. So this is 2 or 4. If it's 2, it could be with 1 or 3. If it's 4, it has to be with 1. So this is 1 or 3 also. Okay. This, again, cannot be 1 or 3. If this is 9, this just becomes 3, 6, which forces that to be 1. So this is 5 or 7 in that case. If it's 7, this would obviously be 9. Oh, these two digits must add up to 9, right? This can't be 8 anymore because we've eliminated the 1 from this box. Therefore, this must be 4. This must be 8, which forces this to be 5. So this can never be 5. So you can never have this being 6. So either this is 9, which means this is 3 and 6, or this is 7, in which case this is 1 and 6. Either way, this is 6. So this cannot be 5. Okay, so this can't be 5 then. If this is 5, so this can't be 5, which makes this can't be 4 here. This can't be 6 anymore, which means this can't be 3. Where is the 8 in box 8? Cannot be here, obviously. It could be one of these two or this one. So if this is 8, this becomes 9, and this is 3 and 6. So this could be 8, and that would be 9, and then therefore this you would have 3, 6, 3, 6. If this is not 8, one of these two has to be 8. So this could be 9. You could potentially have 8 here and that 1. And that, I think, would work. Or this could be 8, and you would have 1, 7, and 1, 7 here. So those are the possibilities that include 8. And therefore this would be... So, interesting. Okay. So again, if this is 8, this would have to be 9, and therefore this would have to be 3 and 6 to add up to it, because those are the only possibilities, because 2, 7, 4, 5, and 1, 8 would be eliminated. So this would be 3 and 6. Otherwise, this could be 8, in which case this is 9, and this is obviously 1. So then again, we have a 1 or 3 here. Or this is 8, in which case it can't be 2 and 6 adding up to it, or 3 and 5 adding up to it. Therefore, it must be 1, 7. So this again has a 1 or 3. This must be 1 or 3. This must be 1 or 3. Therefore, in the rest of box 8, you cannot have a 1 or 3, which makes this a 5. In the rest of the column 6, you can't have a 1 or 3. Therefore, this can't be 1, which means this can't be 8. So this must be a 5. To add up to 9 with this digit, this must be a 4, which makes this an 8. So this can no longer be 4. This is a 5. Since this is 5, this can't be 5. So this must be 3, which means that can't be 3. This must be 1. In addition, this adds up to 3. Therefore, it must be 1 and 2 here. So this is 1 and 2, which means this can't be 2. So this is 5. This must be 4. This can't be 1 anymore. This must be 3. 3 and 6 add up to 9, so this must be 9, which makes that 7. This can't be 3, so this is 1. Again, these are 1 and 2. This is 1 and 2, so this can't be 1, so this must be 4. Therefore, 9 cannot be here. Therefore, this must be 9. And this can no longer contain a 1. Therefore, this must be 3 and 6. So this can't be 6, which makes that a 7. This now becomes an 8. This can't be 7, so this is 6. This can't be 6, so this is 3. This can't be 3, so this is 6. Again, this must be the 3 correspondingly, and this must be the 6. We have 7 and 8 now left over in box 5. So this must be 8, and this is 7. This can't be 6 because of this 6, so this must be 3. This must be 6. This cannot be 5. This can't be 7. And this can't be 8. This can't be 8. This can't be 7 anymore, therefore this is 5. There's no 5 here in these two cells. So what do we have? This can't be 5. Because of this 5, we have a 6 in one of these two cells, but this can't be 6 because of that one. Therefore, this must be 6. We have 2 digits adding up to a 6, which must be unique. Cannot be 5, though, so it can't be 1, 5. Therefore, this must be 2 and 4. This can't be 2, so this must be 4, which makes that a 2 to add up to 6. This has to be greater than 6, so this must be, or sorry, greater than 5, so it must be at least 7 or 8, which makes this 7 and 8. Therefore, this can't be 4 or 7 or 8 because of the 7-8 pair. Therefore, this must be 5. This can't be 2, so this must be 1 or 4. Can't be 4, so this must be 1. The 2 cannot be here. Therefore, this is a 1-7 pair. This can no longer be 1, so this is 2 or 4. 2 or 4 must be with 1 or 3 to add up to 5. We have a 1-2, 1-2 pair in box 4 that eliminates a 1 in the rest of the box. Therefore, this cannot be 1, it's a 3, which must add up with 2 to add up to 5. So therefore, this is 4. This has to be a 3. That's 3 in the corner. We celebrate. To add up to 7, this must be 2. To add up to 8, it must be 3. And 3 is not allowed because of this 3 and that 3. Therefore, this must be 2, which makes this 7, which makes that 8, and makes that 7. This can no longer be 2, so this must be 1, which is the same as that digit, so this must be 1. This now must be 2, which makes the same as that digit, so that's 2. Okay, what is the rest of this column? It has to be 4, 5, 7, and 9. This cannot be 7 or 9. This can't be 4 or 5. This can't be 4. What about the rest of this row? Excuse me. It must be 2, 7, 8, 9, but this can't be 2. This can't be 2 because it must be greater than 4 or 5. Therefore, the 2 must be here. So this is 2. And we have 7, 8, or 9. This is 7, 8, or 9, and this is 7, 8, or 9. And those are both possible. Okay. Let's see. This can't be 9 because of this 9. So this is 7 or 8. If it's 7, it has to be 3 or 4 or 2 or 5 to add up to 7. But that's not possible because both 2 and 3 are already in box 4. So this cannot be 2 or therefore this cannot be 7, which forces this to be 8, which means this cannot be 8. So this must be either 4 with 4 or 3 with 5. It has to be 4 and 4 then, which makes this 4 and this 4. So this cannot be 4. What's left over here? We have 1, 3, 5, and 6. 1, 3, 5, and 6. This can't be 3 or 5. This can't be 6, so this is 1, 3, or 5. This 2 can never add up to 9, right? Because it would have to be 3, 5 at most, so this can't be 9. 6 must add up with 1 or 3 to make 7 or 9, right? We know the 6 is here. So this is either 6 with 1 or it's 6 with 3. Therefore, this is 5. It cannot be with 1, so it must be 3 and 5, adding up to 8. So therefore, this can't be 3. This must be 1 and 6. So 1 and 6 adds up to 7. So this is 7, which forces this to be 9. This can no longer be 7 or 9, so this is 5. This can't be 9, so this is 7. The 5 and 9 are eliminated here, so this must be 7. And now we're just doing Sudoku, I think, right? So where is the 9 in box 3? It must be here. This must be a 3. We have all the 2's? We have all the 2's. What about the 1's? 1 cannot be here, or here, or here. So this must be 1. Do we have all the 1's then? No. This can't be 7 by that 7, so therefore this must be 1, which makes that 7. That 1 is eliminated by this, so therefore this is 6, which makes that 1. This can't be 3, so this must be 5, which makes that 3. What's left over here is a 9. We have 5 and 8 here. This can't be 5, so this must be 8, which makes that 5. This must be 9 left over. We have 5 and 6 here, so this can't be 6, so this is 5, which makes that 6. This must be an 8, and this is a 4. And that's a solution. Fairly straightforward. Pretty cool how this works, and we're evolving with it. I don't really know if we're really evolving, but it was very interesting. Yeah, the zipper lines, plus particularly this part, and then the black crop key pairs, made things very interesting here. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.